Lit Dead. Ah, dear. Yeah, so the previous 2 days, I was out cold. Um, yeah, on Saturday after the stream, uh, I started getting a backache. It was really weird. Not standard kind of backache, I guess. It was kind of a weird thing. Um, More like joint pain, but in the back. And it just kept getting worse and worse as the evening went on. And I also got super tired. And typically on Saturday evening after the stream, I actually watch a movie with my friends or play some games. And I just had to quit and go to sleep. And on Sunday, I was pretty much out cold all day. I had like my body was just heating up massively, and then it was freezing again, and the back pain just continued, and then my eyes started to hurt, and it was really bad. And so I spent most of that day feeling like complete garbage physically, and lying in bed, sweating through everything, and drinking lots of tea and pissing lots and having a miserable time. And then because I slept all day, I couldn't fall asleep in the evening once I actually did feel a bit better. And I didn't fall asleep until like, I think 1:30 in the morning, and then I woke up again because I'm used to waking up at 7 o'clock. Ah, God. Anyway, so yesterday I was already feeling quite a bit better, but still not dandy. And this morning I still felt kind of a little bit of back pain, but already a lot better. And actually, today I had to help my brother move a couch. So that was quite a bit of physical stress in there as well. But I seem to have survived everything until now. So it appears that I'm healthy again. I don't know what it is, but certain types of illnesses, I think this was kind of a type of the flu. I'm not sure. But ever since I was a kid, certain types of illnesses I just have really, really strong for 1 or 2 days, and then it's gone again, essentially. Which, it sucks for those 2 days, but I'm glad that it typically doesn't go on for any longer than that. Anyway, let's get some good music going here. And yeah, so last time we had 2 sessions on the particle system, which yesterday.
Good to hear you're better.
Yeah, thank you. Yesterday and today I spent a bit of time refining, so I added a bit of stuff, and I published an article on Gamedev.net and my usual blog about how the particle system works. So if you're interested in seeing that and explained a bit, check that out. My stuff is on blog.tymoon.eu, or I think blog.chimera.com should also work. Let me check that real quick. Yes, it does. Okay. Anyway, so I think it's high time that we return to Alloy, because I don't think sitting around and not really doing anything with it is going to help. So tonight we're going to continue that. I stopped working on it for a while because I was unsure about the layouting protocol and how that should work. And honestly, I'm not sure I can figure out how it should work without proceeding at this point. One thing though that I did change was to have... So we had this function called notice bounds, or I think I called it notice extent previously. Changed it to this. This function was supposed to be used if a child element changes its sizing behavior. So if it wants to change its extent due to some kind of user interaction or whatever, maybe a new element was added, or the user resized something or whatever, then notice bounds is supposed to allow the child to notify the parent that something has changed, and the parent should then be able to recompute potential layout parts of other children in the same thing. So for instance, if you have a vertical stack of things and you resize one of them, then obviously the ones below should be shifted downwards. And so notice bounds allows the layout to react to these kinds of changes. Now, you also need a way of going upwards in the hierarchy. So if the layout does its layout reconfiguration, it should have a way of telling the component that it wants, or the element that it wants, to change the size to something. And then if the element has anything to say about that, it should be able to somewhat influence this decision. This is mostly because of things like flow layouts or flow elements, which is to say, the easiest example is if you have a label that has text in it and the text should be wrapped. So if the width is at a certain point, its height should ideally change. And so the layout can't know about this. The idea now in this protocol is that the layout computes some kind of size for the element, calls suggest bounds with that size, and the element can then do, based on the width or whatever, for example, can then compute its ideal bounds. It should compute the ideal bounds as close to the extent that it is given. So it'll try to do a closest fit to the suggestion that the parent layouts gave it, and then it'll return that actual new extent without actually changing its own, but it's going to return that new extent. Or might change its own, doesn't really matter. Either way, after that, the actual parent layout then gets to make the final call, which is to either accept this new suggested extent or clip it. So if it's going to get clipped, obviously that's not ideal because you're going to lose visual information. But what can you do? You can either accept it or you can discard it. There's not really anything else that can be done. I suppose you could do something where it tries to recompute the layout again based on that, but I don't think that's a great thing to do because then you run into stability issues where it might take infinitely long to find a stable configuration where every bound is satisfied, or there might not even be one at all. So I think this is a reasonably good approximation. The good news about all of this is that most elements will simply accept the suggested bounds anyway. If you think about it, most elements just have a fixed size and do their own clipping, rather than having some kind of flow layout. So, for instance, most labels, text inputs, fields, or text areas, or radio boxes, or whatever you want, usually they fit onto a fixed size and don't have any kind of wrapping or otherwise dynamic sizing constraints based on a size. So there's no kind of recursion going on in almost all cases. So this is really only for components that have some kind of flow layout. And Jesus Christ, I wish my birds would shut up. They're good boys. I love them, but okay. So that's the basic idea behind the protocol for now. Right. So that leaves us on the things to do. That leaves the rendering API. and the file chooser thing I haven't thought about. And then defining actual layouts and actual renderers. So in the spirit of continuing on with defining all of the protocols first, I'm going to define the renderer protocol. And so we're going to do that. Now, as it stands, the idea is that the renderer gets control over how each layout element and component is actually displayed. So it can make these decisions arbitrarily without any influence from the element or component at all. And that's fine, but typically when you're writing a new system or whatever, you would like to have some kind of default behavior. So you would like to have a default rendering style for all of the elements, so you don't need to repeat that work for everything. And in order to do so, we're going to need an API that allows us to draw most things. And then a client can decide to either do everything themselves or to implement this protocol, this sub-protocol, and get rendering logic for the components for free, and also do customizations based on that protocol and so forth. Okay, so this protocol should be somewhat minimal. We don't want to force too many things onto the client to implement, but it should be enough so that we can draw a reasonably looking default style. So I'm just gonna create a I'm gonna create a directory renderers, and we're gonna call it simple.list. And actually, I think since this is not necessarily part of the core, I might make a new package for this. Yes, core package is already big enough. So, the package. What do we have? Render simple. And we're gonna simply use cout and make use of the incredibly nice local nicknames feature that we can now finally enjoy in most implementations, or most reasonable implementations. There we go. And yeah. Oops, don't need that yet. Okay. So, first we create a new subclass for this stuff. Simple render. Alloy render. Alloy does not exist because I forgot to add the package. Oh, right. There we go. Okay. Hello, Finn. Good evening to you as well. Right, so the base protocol in Alloy mandates these three functions. And the simple renderer can't actually do anything with these, so we can't provide any defaults on what to do with them. Unfortunately. Or at least I don't think we can. But we can define additional API functions that need to be implemented. So let's get on to that. I think I already went over the types of things I thought about on a previous occasion. So let's look at that again. Um, Actually, I might want to add another thing here. Okay, the P. Maybe. I'm not sure. Yeah, it would be good to be able to check that. So... Okay, let's also export that real quick. Okay. I'm not sure yet whether I want to do checks for validity there. I'll think about it. Okay. Anyway, back to this. There's, as far as I can tell, there's 4 different kinds of categories that we have these functions in that the base API of the simple renderer should provide. So, the first one is transforms. And I'm not sure whether... we're just going to put everything in a single file for now. So for transforms, we have push transforms, pop transforms, where push transforms. I'm not sure if I want to include a shear, to be honest. Okay, let's not for now. So this is the transforms API, and I think this should be sufficient. Basically, we're going to define a transform stack to which we can push and pop, so we can sort of apply transformations and then safely pop back out. This is going to be very useful for dynamic extent stuff. Then we're going to have a function clip that is going to clip the rendering region to a certain extent. We're going to have a function translate to move the transforms somewhere, scale to scale, and rotate to rotate. In 2D everything. Yeah. That should be sufficient for the kinds of transforms you should be able to apply, as far as I can tell. Now, Right. Aside from the transforms, we have something very similar for what I call the style, I guess. I'm not sure if that's the best name for it, but I guess style. So for the style, we again have a style stack. Uh, push styles. Pop styles. And for the style actually defines sort of the visual attributes of what things look like. So we have a current color, which is setifable. We have a line width. We have the current. This is one I'm not sure about, is the, I guess, mode. Whether we want to draw lines or whether we want to draw filled shapes. I don't know what to call that. Fill mode, maybe? Hmm. And finally we have the composite mode. Which defines how colors are blended on top of each other. Okay, which kinds of composite modes I want to support is up for debate at this point. But that should be enough. I've been debating on whether to include a protocol for gradients, but I'm kind of unsure about that one. I don't know. Yeah, I don't know yet. Gradients are kind of... Of course, they would allow a lot more effects to work, but I don't know yet. Let's put that on a to-do for now. Okay. Finally, we have the actual drawing logic itself. So, how we draw stuff. And for this, we're gonna have a couple of commands. So, simply line point A, point B. Rectangle, extent, ellipse, and a polygon, with the point sequence. Finally, we have text. Now for the text, this is not how I'd like it to be. For the text we're gonna need, because text is one of those flow layout problems, we're gonna need an additional function that tells us the actual, or does the text wrapping for us and gives us new text to render with the wrapping in place, as well as the current size. So we're gonna need a function, a utility function that gives us the wrapped stuff. Wrap text. I think. I'm not quite sure about this one yet. And finally, image. Drawn image at a point. An optional scale, I guess. And clear. There we go. Now for fonts and images, those obviously need to be allocated ahead of time, so we need a couple more utility functions. Aside from the text wrapping thing, which is a allocate or request font, I guess. Font spec. And that. Okay. Right, this should be everything I can think of. Alright, one question though is like the default size to supply here, which I suppose I could add with more styles here. I think I will. Font. There we go. So that should be the complete protocol for everything. Whoops. So now comes the job of actually filling that protocol in. Alrighty. Or filling as much of it in as we can while leaving the rest up to the client. What we definitely can do is do this stuff, or at least we can offer a default implementation that will keep track of transforms for us. So we shall do that. Or should we? I don't know. Typically, most rendering things will have their own ideas of how to do transforms and stuff. So maybe... Hmm. I don't know. In any case, we definitely can implement the macros. Those are trivial. So let's actually pull these down here. There we go. Styles are maybe a bit easier. I don't know yet. Can't decide what's easier or what's better, whether to provide a default or not. Maybe more subclasses is the right call here. Simple styles render. Simple render. Hooray, so this one is gonna have a style stack thingy. So we're gonna make a class for the style here that is going to contain all of these properties. Okay. So the color line width, fill mode, object mode. That's font size. Okay. Thinking about how to handle this because I do want to ensure correctness. So I wonder whether I should want to do that on the style or in these methods. Hmm. There we go. And on this, we simply copy over slots that were not specified. So unless not P. There is now, asshole. Okay. Good. So with this, we're always sure that each of the fields in this style is either given a new from an option or initialized from a parent. Okay. So with that, we can implement push styles. Sample styles. And this is simply going to push style parent style render onto style stack render array. There we go. That's those two implemented. Now we need to actually provide all of these methods. Okay. this downwards. Actually, we do need another protocol function to provide us with the default style that renderer should use. And here we replicate that by using class of, so that if the client decides to create a subclass of the style to maybe add more properties or whatever, then this won't ruin the stacking. Okay. Now for the actual properties. Let's go. So we have accesses here, and I have decided to simply add before methods on the setf stuff to provide the checks for everything. Okay. No, wait, this is not how that works at all. Style. Okay. For colors, I was thinking of simply using a list of RGBA triplets, or quadruplets, I guess. So, yeah, I don't actually know if I feel okay with this. The problem with adding the checks as before methods is that it's annoying for the client to add further types as allowed values, so I'm not sure. It would be better to not have accessors at all and instead use custom setter functions, setf functions that specialize. But then it would also be annoying to add more, but it would be less annoying maybe. I don't know. I think I shall make these readers after all. And so these become primary methods. So the line width becomes a float. The fill mode becomes a symbol, as does the composite mode. The font becomes something. Font size becomes a float. Slot value style. For the font, I'm wondering whether to use a default class that needs to be subclassed for the fonts? I don't know. Uh, hmm. Sometimes that constraint can be a bit harsh. Sometimes not. I think I'm gonna do it, so we're gonna have a div class font and a div class image. Actually, we're gonna put these top here. Okay. Again, the color is gonna be icons. Or should we make a color thing? Probably should. So we're gonna make a color struct in this case, because there's no point in extending it. Color. Oi, 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 oi. Oi, oi. So mad. Alright, default needs to be something. Ah. I forget if this is the proper way to do that. Right, needs to be type. Yes. I think it's constructor, I don't. And that's color RGB optional A. Okay, great. So actually, I think on the last stream I complained about print object methods often not being composable due to the wrapping in print unreadable object, causing, because that wraps stuff in itself, you can't actually call other methods because that would double wrap or do things odd. And he actually has a pretty interesting system that helps with that or makes it much more composable, called, I think it was utilities.printItems. So if you've come across this problem again, check that one out. I've talked with him about a couple of potential improvements, and I might actually make use of it in trial and stuff like that, because there it really starts to bite me. For here, though, we're gonna just do the standard readable representation, which is list color. A color. And actually there's something I forgot to do. Make load form is another thing that we should be doing for this. It's not terribly important. And for the extents and stuff as well. I'm not sure if structs are automatically dumpable. Probably not. Where I don't remember. Geometry. Right. The reason why in the layout protocol I renamed things to notice bounds and suggest bounds is because I wanted a more convenient printing representation and constructor representation of points, extents, and stuff, which is just extent and then the values. But that would have conflicted with the accessor, so I renamed the accessor in those things to bounds instead. Okay, right, I wanted to add that. Oh, right, I also need a wrapper, I forgot. Here. Like this. Yeah, we can actually do that. Point X, point Y, point. For the size, the same. Except we're not gonna use that. There we go. Okay, now I just need to fix this up. Use the new constructor. Defun curve. RGB optional A. And because why not? Good measure, add that in as well. There we go. Alright, new color thing. As you might notice though, because, you know, things are so similar between all these structs, it might be worthwhile at some point, or for projects that have even more than those, to define a macro to do all of that setup work. Okay, anyway, so we have colors and fonts and stuff and things, and hooray! Alright, so now all we need to do is actually hook up the renderer ones to the style methods. And these are all just gonna be simple delegates. So renderer, simple styled renderer. They're all gonna work exactly the same way. Well, almost. Style, stack, render. Obviously, the setf ones don't work quite as well. fix these up. Here's the color with... no. There we go. Alright, whoops, something went awry here. That's weird. Here as well. Okay, let's just compile the file. Continue. Oh wait, never mind. Color already defines a function, so let's just call this fill color instead. Oh boy. Initialize instance. What the fuck? Oh, right. What? Ah, that's still not made wrong, right? Okay. Good. Okay, fantastic. Fantastic. That should take care of that, except for one important thing, which is we shouldn't be allowed to pop the style of the lost one. So after we do the pop, unless style stack. So if we don't have one anymore, if the stack is completely empty, we'd simply reset to the default and do this. There we go. So if you pop off the stack, I guess it resets to default no matter what you do. Okay. Yes. Yes. I actually, whenever files get even slightly long, I feel claustrophobic, for a lack of a better word. So I'm considering actually pushing this stuff into a separate file already to have a protocol and things. So, yeah, I might probably gonna do that. So let's do make directory simple, and then we're gonna name this simple protocol list. Paste that there. And we're gonna do this stuff. Style. some reason I'm still used to the arrow keys instead of the Emacs standard navigation keys. It's annoying, because it means my hand moves off the home row. Okay. Good. Alright, so now we can again do the same thing for the transforms. I'm not sure why there was a space there. Makes me worried that I accidentally cut something out. Oh right, the macro, that's fine then. Right, transforms, defaults. Again, a large reason why we can even do this nice separation of concerns is because we have multiple inheritance. And multiple inheritance is an absolute gift. If your language of choice does not have multiple inheritance, or if it doesn't have linearized inheritance, it's probably not a great system. It's a mistake. Okay, so we're gonna have to do something very similar to the thing here to define our stack. So we're gonna have a def class transform that holds our properties, and we're gonna have a, what was it called? Style. Whoops. Gosh damn it. Simple style renderer. Simple transform renderer. Simple renderer. Transform. Stack. Now for the transform, things are going to be a bit different though, mostly because you might naively assume that we're going to just have a slot for the translation, the scale, and the rotation, and the clip mask. Unfortunately, that's not how that works. The reason is that the order of translation, scales, and rotates actually matters, so it's not, you can't shuffle them around arbitrarily or combine them in any way you want. The most simple example being a translation followed by a scale is not the same thing as scaling and then translating, because the distance of the translation is going to be different. So the way you typically do this is through a matrix that encodes this, and whenever you do a transformation, you multiply a transformation matrix with the current matrix and then store the new matrix that results from that. Now, I don't want to be writing a matrix library again. So I'm a bit unsure about how to go about this. I'm also not entirely sure about how the clipping fits into all of this. I think the clipping needs to be separate from the transforms, or from translation, scaling, and rotating. I don't know. I think it needs to be. So we're gonna have clip mask and a matrix, I guess. Now, at least for this, we only need a 2x2 matrix, so it's not too bad. So actually, get method clip. Actually copy things over, so wait, do we need a... Hold on, let me think for a second. Yeah, we need a 3x3 matrix because of translations. So I wonder... Yeah. Okay. So we're gonna use simple things and do a very primitive matrix library in this, I guess. Matrix transform is gonna be... Wait, that's not translating by an extent, by point. Okay. For translation, it's gonna be... wish I had a convenient notation notice. I'm gonna have to make do with this. 0. Go. That's how you do a translation matrix. Scale. Exported yet? Tree. I guess not. Bad. Okay. Size. Size P. finally rotate. Let's just do it like before. Maybe we should also add a or maybe like add. Yeah, that'll be better. Fuck. Okay, rotation was. Bobby asks, what exactly is this Allo project? It's a user interface protocol and implementation for, well, it's both more and less than what is typically called a user interface toolkit. So that's what we're working towards. Mostly because the game engine currently lacks any kind of convenient way of representing and doing UI, so I want to have a system to do that with. Okay, rotation was cosine minus sine, sine cosine, I believe. For the matrix, let me check a look again real quick. Just to be sure. Cosine minus sine, sine cosine. Right. Yep. Good. Minus. There we go. Oh, wait, no. It needs to have zeros filled in. There we go. Because it's gotta be a 3x3. So that transforms in theory. Still need to add the actual matrix operation multiplication stuff. Matrix. Make ray. Is like 9. Float. And we're gonna place. No, replace doesn't have a map into is what I want. Exactly. Matrix values. No, it's x float x 0, 0. So this should create us a matrix at all times and ensure that we have the floats mapped. Good. Obviously, could add another pile of macro to make this a bit neater. I think I will. I don't think I need a hole, so... Yeah, again, gonna be very similar to what we did before with the folding thing. Just in this case, we're not gonna do it like this, we're simply gonna use make array instead of this constructor. I'm gonna use... I think it's better not to construct an intermediary content vector, so we're just gonna set the elements immediately. Value. And now we need a gensym. Okay, let's have a look at this one, see if that works out. Okay, transforms that correctly, load time value of the float, yes. Otherwise, coercion at runtime, yes. Good. Okay, perfect. Looks fine and dandy. So that's matrix creation sorted out. Now we just need multiplication implemented. So, probably just gonna type this out, honestly. Instead of, well, I don't know, could loop it, but yeah. Actually, let me quickly see what's in 3D matrices. Probably an unrolled loop. Let's see. Ooh, yeah. Look at this. Okay, it doesn't unroll. Oh, it does a generic unroll with macros. Okay. Yeah. Okay. Could do that, I guess. What is MEDF? I don't remember what MEDF is. Probably float coercion? No. What is U? Oh. Oh, the result, I think. Target. Unroll M. Oh, matf is, I believe, mat fill, maybe? I don't remember. Yeah, 3D matrices is a thing, and yeah, that I've wanted to replace for a while, but I just never get around to it because it's not high priority. The current system works, and I really just don't want to touch it until I have a very smart idea and a lot of time on my hands. So it's gonna stay in its horrid state for quite a while longer, I suppose. Okay. Here we're gonna just do it in a macro that just does the unroll like this. And the way you do matrix multiplication is you do row by row. So we go from from 0 to 3, or below 3, to, in this case, and C from 0 to 3. Plus times B from column. Hold on, let me think for a second. Column is gonna be same, but the row is gonna be different. Okay. Oh, whoops. Alright, so I never used. Where is that used? Oh God. Legal function call. Oh right, we never actually set the thing. Whoops. Set R. function call. Well, let me see. So we're gonna do this. Paste that in. Okay. Oh right, it's not unrolled in here. So ugh, horrible. So hold on, let me actually see again. If R plus 0. This is not correct. Right, so I always get confused about this crap. Let me quickly see. Okay, so in A it needs to be column that it wants is there we go. Now I can pause. Let's look at this again. So here we advance to column and there to row. Okay, it's 1. That is not correct. Wait, what? Is that not correct? No, wait, it is correct. Okay, 1, 1, 1, 1, 2. Yeah, okay. That looks good. Yes. Okay, I think we're good. That should be correct now. It's a horrible mess. But, yeah, loop syntax quickly becomes very nisty. Not sure what else much I can do to reduce this crap. Guess I could make more functions. Guess I'll make this. So. Yeah. That's a bit better. It's all not fantastic, but you know. Okay, so let's test it real quick. Yeah, it should probably return the result, shouldn't it? Okay. Let's do a quick identity test. Identity, that's another identity, that's great. Scaling by an identity should result in that. 2 scales should be a 4 in there, good. Let's add a scale, a translate, and 2 translates, yes, good. That works as well, fantastico. Okay, matrix multiplication seems correct. Alright, so with that, we have our, well, very tiny matrix library. Can do multiplication, and that's it. But that's about enough. That's all we need for this. So let's go back to this and implement the rest of what we need, which is to initialize the transforms properly.
For what do we need transform?
We need transforms in order to be able to position things, scale them, and stuff like that. Rotate them. Factor rotation is going to be a bit of a problem. I'm not sure whether I should include that. Whew, that might be spicy. I don't know. I'll have to think about it. Spicy. Okay. Whoops. Just gonna copy this stuff. Now for the clip mask, we actually gonna need a special state nil to mean no clipping at all. Gives me a bit of a problem though, is that we currently copy the values over, so we expect the clip mask to always be an extent. Bade. Could argue that like setting width and height to 0 or something like that could indicate no clipping, but I really loathe having special values of any kind like that. Yeah, I'm just gonna have nil. that one. Okay. Or actually, if targets. Go. Okay. I believe that should handle that part. Good. I've also considered using a pre-allocated vector instead of a simple list for these stacks, because in that case you could avoid allocation in most cases, but for now I don't think it's that important, so I'll worry about that later. Make Okay. Now we can implement the deferral of these methods and the push and pop logic as well. Again, gonna be very similar to the style stuff. In this case, so we're just gonna in this case, you don't need a class of thing. We should probably make these defaults. Yeah, I'm just gonna do it manually here. It's fine. It's fine as it is. I'll just copy this stuff. Or maybe I should just make another method like this. Why not? Let's do that. Make default thing. There we go. Much easier. There we go. So that only leaves us to have these clip, translate, scale, and rotate methods delegate to the current transform on the stack. That's going to be very similar to this, at the very least. This is, I know this is not very interesting or exciting stuff. It's just very basic hammering out of all these functions that need to be provided to make the interface somewhat convenient to use. Okay. And that should be it for the simple transformed rendering renderer implementation. Okay. Let's delete this file. Good. Alright. Yes. The rest of these functions, so we have provided defaults for most of the logic of this stuff. In the very least, all of the logic of this stuff. We have also provided most of this for those who want it, but you might have certain changes that might need to trigger changes elsewhere, so not just recording the information, but also changing a backend API like in OpenGL. If you change the composite mode, you need to make a GL call and stuff like that. So it's not necessarily fully handled for the client, but it should be handled to a large extent. We don't have anything for this at all, mostly because we just cannot. We have no idea about how rendering is going to happen at all. So there's nothing for us to do there. And same for this, we don't know how resources are acquired or released or whatever, or how text calculation happens, so this is outside of our interface or protocol definition. What we can provide is standard classes for color, fonts, and images, and the simple renderer as now we have here, and these simple subclasses that we have here. Okay, so that should conclude the protocol of the simple renderer. So now that we have this, we could actually start defining components like text fields and areas and labels and what have you. and start writing rendering logic for it as well. Uh, yeah. Yeah. Actually, I think we can also provide a default for the styles. So I think I'm going to do that. Where is it? So we have the color, fill color, which is gonna be, well, black, I guess. You have the line width, which is gonna be 1.0. You have the fill mode, which is lines. The composite mode, which is I forget, what is it called? Source over, I believe. Font, which will have to be that, I guess, and font size, which is gonna be some arbitrary thing. There we go. Okay. So next, we could also try to implement an actually working renderer backend that allows us to draw stuff. And I've been thinking about multiple things to do there. One obvious thing that we're going to need to do at some point is a OpenGL backend. The reason I've held off on that is because it's actually very far from trivial to do so because of, well, the question of how resource allocation is handled and the question of how text is rendered. So my hunch is that it's not going to be possible to do this as a generic, just OpenGL backend. We're gonna need to do that in engine specific to trial. And yeah, so we might do that. We're probably gonna do it like that at some point. But before that, I was thinking we might be able to do it much more easily by doing something like rendering to an SVG file. So instead of having, something that renders continuously, we're just going to be spitting out an SVG file when we call render. And I think the SVG file format should be easy enough to deal with to implement this without too much pain, especially now that we have most of the other stuff already handled for us. Yeah. Alrighty. Before I leave, though, let me quickly do the package stuff here and export all these goody functions. Okay, there we go. That should be all of the things, unless I made a typo, which is entirely possible. Uh, Alright, I also need to add things to ESD. Okay. And pushed. Alrighty. So, next time, a rendering backend, most likely. I'll still experiment a bit with layouts on my own if I find the time, just to make some headway there as well. But next time, we're hopefully going to be able to actually see some stuff, maybe. Visual output is always nice to have. Being lost in just text for so long doesn't feel very well. Feel very good. Doesn't sit well with me. Anyway, let's end here before the music gets any more ominous. Alright, thanks everyone again for joining me. I hope I won't have to fall ill again anytime soon and set out streams and stuff. Yeah, but I should be fine again now. See you again tomorrow. Good night.
I hope so too.